or an NPN na, the formula, our very basic formula will still be the same na. That is, kung titingnan mo, ano, you have here the emitter current going out. Let us just look at this as a node, ano. So going out of the node na, and then you have here the IB and the IC, ano. Same also for the PNP, ano. Sa PNP naman, your IE is entering this node, and the IB and the IC are leaving. So therefore, the formula for your BJT, whether you have PNP or NPN, will be the same, ano, for the computation of the IE or the emitter current. Emitter current, collector current, and then the base current. Okay. So please remember that the largest, ano, pinakamataas, ano, na value of current is the emitter current. Pinakamaliit is the base current. If the given is incomplete, you can actually approximate IE to be equal to IC. Ano? You could do it, ano? Basta kulang ang given. Ano? You could have IE approximately equal to IC. Why? Only do that if the given is incomplete. Na? Now again, what we are following here is conventional current. Na? The actual current, pabaligtad. No? Ito sa NPN, papasok to, itong dalawa palabas. Sa PNP naman, ito palabas. Sa IB and IC, papasok. Ano? So that is the actual current flow. But we will be using the conventional current flow. This one, no? Yan yung conventional current flow. Now, there are two important parameters of the BJT. You have the beta DC and the alpha DC. And they are current gains. They are how do you call this? Current ratio. The beta DC is your DC current gain. And then the alpha DC is a ratio of currents. The formula for that, this one is IC all over by IB. So since you know that your collector current is large, compared to base current, so you will be anticipating here a value which is very, very much greater than 1. So you will be anticipating here a large value because your collector current is large, compared to the base current. So syempre, if you have a number which is big, and you divide it by a number which is small, so that means your quantity, in this case the beta, will be a big value. You can also drop the DC. You could just simply write it as beta, that is okay. Or you can write it this way. You call, dito nakalagay, your beta is a DC current gain. Bakit current gain? Because gain is actually computed as output over input. So in this case, the output current is the IC and the input current is IB. Do not forget that. This is called the DC current gain. Gain pertains to output over input. In this case, the output, when it comes to current, dun sa configuration that you will see later, the output is on the collector side and the input is on the base side. So you call this as the DC current gain. Yung sa alpha naman, you just simply call it as current ratio of currents. You will see here. It is the ratio of collector current to emitter current. You do not call this as gain because the value that you will be getting here is actually less than 1. If you approximate IC to be equal to IE, then your alpha will be exactly equal to 1. But in reality, IC naman is not equal to IE. IE is very much greater than, no, sorry. IE is greater than IC. A little bit greater than IC, you know? So, syempre, if this is a small number, if they are approximately equal, ano, IC being smaller, so ibig sabihin, the alpha that you will be getting is something less than 1. Okay? So, typical value of alpha is this, ano? So, you do not call this as gain, ano? Kasi hindi naman to out over in, ano? This is just a parameter that is the ratio of collector current and emitter current. Na? You will never get a value here which is so large. Kaya malalaman mo if the values that you are getting are wrong. Ano? If you get here an alpha which is so big, then your answer is wrong. Or maybe the given is wrong. If you get here a beta which is so small, like less than 1, na, so that means your solution is wrong or the given itself is wrong. Ano? So, dapat magtataka kayo, no? Pagka ganun ang nangyari. And then you have to ask your teacher about it. Now, you have here, di ba? If this is your basic formula for the DC current gain, na? And then this is the ratio of your alpha, the ratio of your IC to IE. This is just a derivation on how you are able to get this. Like for example, you are just given the beta, ano? You can calculate for alpha using this formula. If you are given the alpha only, you can calculate for the beta using this formula. Written naman here is the step-by-step procedure on how you are going to derive these two formulas. So this is just a very simple algebra. You know that your IE is equal to IC plus IB. You simply substitute this. You know that IE, when you do the algebraic manipulation of this, you know that your IE is equal to IC all over by alpha. Ito yun. Plus equal to IC plus, and you know from this formula na that IB, do the algebraic manipulation, your IB is equal to IC all over beta. Ito. So you can cancel all those ICs, so you are left with this one. You do the algebraic manipulation for this, and then you will come up with this 2. Hindi ko na gagawin yung algebraic manipulation because that is just algebra. You could just, very simple naman, you could just manipulate that later when you are studying. Or, better yet, maganda if you know how to manipulate. Para pag nalimutan niyo yung formula, you just, ito kasi, you will not be able to forget this. Itong dalawa, I hope you will not be able to forget this as well. Ang palatandaan lang naman dito, ang nasa numerator para sa kanila is IC. Ang nasa denominator, kagaya nito, ano yung makakapagpabigay sa iyo ng malaking value? Of course, it will be, the denominator will be IB. Isa pa rin palatandaan, kung beta ito, B ito, IB. So, dito naman, wala ka ng choice. So, this is IE. Kung IC ang numerator, paano ito magiging approximately equal to 1? So, your denominator surely will be IE. Impossible na IB. Okay. So, determine the DC current gain. Okay. Can you solve that number 1? You have your calculators with you, right? You have your calculators with you. So, what is our formula? Beta. Ang tinatanong dito ay determine the DC current beta. So, your beta, wait lang. Okay. So, your beta is equal to, what's the formula? IC all over by IB, right? So, Therefore, when you, given naman yan, you just substitute the value. So therefore, beta is equal to 3.65 milliamperes divided by 50 micro. And what is your answer for that? Somebody talk. Hindi chat. Wag chat, please.
73 amperes.
Okay, so 73. So your beta is equal to 73. Pero mag-talk yung gustong mag-chat, yung gustong mag-talk, that's nice, if you will answer verbally, and then you can chat as well so that your classmates can see, and then so that I can see it afterwards, kung sino yung mga sumasagot, okay, nagre-recite. And then, you know that your IE is equal to, simply the summation of the IB plus IC, So you can simply calculate your IE by simply adding IB and IC, So you add those two and you will have 3.7 milliampere, So that is very easy, How about this? A certain transistor has a current gain of 200 when the base current is 50 microampere. So what is 200 here?
Beta.
Okay, beta, So, syempre, number one, sinabi na current gain. Yung alpha naman kasi, you do not call it as current gain, Another thing, 200. So, impossible na yung alpha mo ang 200, So, therefore, again, your formula is equal to beta equal to IC divided by IB. So, therefore, you calculate your IC to be equal to, IC is equal to beta IB. Ito, mamememorize nyo na itong mga formula sa kalaunan na to. So, determine the collector current. So, the collector current will be equal to 10 milliamperes. So, 50 microampere times 200. So, you have that as 10 milliamperes. So, by the way, whenever you are writing current, you usually encounter current which is like, for example, on your exam, a current of 0.965 ampere, So, better yet if you will write it as 965 milliamperes, Yung mga maliliit kasi kapag ginawa mong 0.97 ampere, yung 0.965, ang mangyayari doon, your calculations will be, yung mga succeeding calculations nyo will be far from the exact value, Okay? So, mas maganda kapag currents, you use microampere o kaya milliampere, so that you will be able to get more numbers, And then the last one, a transistor has a collector current of 2 milliamperes. If the current gain is 125, what is the base current? So that is simply algebraic manipulation. IB is equal to IC all over by beta. Okay? So the answer is 14.8 microampere. True enough, because IC is only a milliampere and a beta is hundreds. So true enough that your IB is very, very small. And that's actually the value of IB, yung mga small numbers like, for example, microamperes, Kapag ka nasa experiment, usually the IB is being calculated kasi it is so small. Kagaya nyo, you are using ECEDA, you can read that, yung mga small currents like the IB, you will be able to read that. Pero sa face-to-face, pagka nasa lab kayo, you will have a hard time, reading a microampere, Usually, that is being computed na lang. What you usually read are the IE and the IC kapag ka-actual. Pero pag simulation, like ngayon, hindi tayo face to face, yung sa lab ninyo, no problem with reading a microampere na. Now, for the BJT circuit analysis, this is just a DC analysis, ano? Kung makikita nyo, wala naman tayo pang input, ano? The VBB and the VCC there, they are not inputs yet, ano? They are the bias, ano? So, ang naming convention natin, we use the IB, IE, and IC, ano? Use the capital letters for the B, the C, and the E, ano? Kasi meron pa later on when you have the BJT AC analysis naman, you use naman small letters for IB, IC, and IE, ano? So in this case, ano, you do not have yet the input, ano? The VBB and the VCC there are simply bias, no? Now, when you have a VBB, ito naman yung naming convention, ano? Pagka double subscripts, like the VBB and the VCC, usually you use that for voltage source, ano? VBB, VCC, VEE, etc., ano? So, pag naman subscripts are different, meaning you are measuring voltage across 2 points. Like for example, dito sa VCE, ano? So that means you are measuring the voltage across collector and emitter. Okay? VCB, you are measuring voltage across collector and base. And then the kulang to, VBE, nagkamali lang to. So this should be VBE, no? VBE, that means you are measuring the voltage across the base and then the emitter. Pag naman single subscript like the VC, wait lang. Kagaya nito, no? The VC, a VC here, itong VC na to means you are measuring from collector to ground. Pagka naman VE, you are measuring from emitter to ground. Meron dito, okay. So, this one, as I have said a while ago, the VBB for the supply volt and the VCC, those are used for supply voltage, no? So, dito naman, this is the single subscript. So, ibig sabihin naman ng VB, simula dito sa base, ano, hanggang sa ground ang sinusukat. So, ano-ano yung from base hanggang sa ground? So, ibig sabihin, yung VBE mo dito, at saka yung voltage across RE. Okay? Siguro before, I'll show you first where VBE is. Ano? The VBE is here. Ano? It is actually 0.7 volt para sa silicon and 0.3 volt if your transistor is made of germanium. Ano? So, in this case, ano, dito sa, pagbalik natin dito sa single subscript, pagka sinabing VB, ano yung composition nun? Yun yung, yung voltage dito sa base and then the emitter, and then voltage across the resistor ng emitter. Ano? Pagka naman VE, na ito, pagka naman VE, it's from emitter. Nagkataon kasi dito, iisa lang yung resistor, RE, no, sa emitter. So, it is just the voltage across the RE, ano? Pag sinabi mo naman VC, it is from collector hanggang ground. So, ano yon? Ano? So, yon yung VCE at saka yung voltage across RE. Na, kung makikita mo sa letter C, dito sa kanan, ano? So, dito sa right side, you have here the VCE na, so ibig sabihin, kapag tinanong ka ng VC, simula dito sa, nahirapan ako dito simula dito sa collector hanggang sa ground. Okay? Up to the ground. Okay? So, ano-ano yon? The VCE and the voltage across RE. Okay? Pwede mo rin, pag sinabing VC, there is also another way, that is pabaligtad naman, simula collector, kasi ground din ito eh. Wait lang, hold on. Okay? Ito, pag tinanong yung VC, simula dito hanggang dito. Pag dito ka tumingin, that will be VCE at saka voltage across the RE. Pwede naman na simula dito, yung VC simula dito hanggang dito, kasi itong ground na to parehas lang dyan. Okay? So, ano namang composition na yon? So, hindi ko sinasabing basta addition. Depende kasi sa polarity So, it will be this point, the voltage across this, and the VCC. Sigurado, it will be VCC minus voltage here. Okay? Simula dito hanggang doon. So, pwede ka tumingin, pag VC, pwede ka tumingin dito hanggang doon, o kaya dito hanggang doon. Dapat parehas ang sagot. Pagka VE, simula dito hanggang dito, hanggang sa ground, ang composition, itong VBE at yung voltage across RE, pwede rin naman dito sa kabila. Simula dito hanggang dito. Dapat parehas rin ang sagot. Okay? So, just remember, your base emitter is forward biased. This one is NPN and P. So, P connected to positive. This is for transistor as an amplifier. Pagka transistor as amplifier, i-amplify ang signal, i-boost ka na, ganito yung biasing. Base emitter must be forward biased. Pagka naman collector base, this must be reverse biased. N, PN, N connected to positive. Dapat rin ang VBB mo ay greater than 0.7 para this will operate as an amplifier. Pag hindi, reverse pa rin ito. Kapag ka hindi greater than 0.7, hindi ito magko-conduct. Okay? Now, as I have said a while ago, a VBE for silicon that is approximately equal to 0.7. Ito yon, 0.7 volt. Okay? Now, you take a look at the polarity na very important, This one is NP. N, This one is forward bias. The base emitter is forward bias, positive. So, this is positive. Syempre, this one will be negative. Ayan, negative. The VCE, remember, the collector base must be reverse biased, N, PN. So, positive. Bakit ito positive? Because of this. Okay? So, positive and then negative. N, P, N. So, plus, minus. So, this one is reverse bias. The VCE, the polarity is like this one, VCE plus, minus, plus because of this. Okay? So, you have another formula. VCE is equal to VCB plus VBE. If it is a PNP, same formula. Okay? So, may nadagdag na sa formula ninyo. One is the IE is equal to IB plus IC. The beta is equal to IC over beta over IB. The alpha is IC over IE. And then you have another one. The VCE is equal to VCB plus VBE. The VCE is equal to VCB plus VBE. Bakit VCB plus VBE? Kasi this is a plus minus plus minus. If you have a plus minus minus plus, that is subtraction. But if you have a plus minus plus minus, addition. Minus plus minus plus, addition pa rin. Pero pagka sa liwa, plus minus minus plus, that will be subtraction, sorry. Now, here, ano ba to? Emitter is grounded. This one, you call this as a common emitter, no? Using KVL, the voltage across RB is this. Now, you do not, makikita nyo dito sa susunod, ano, ayan, nandiyan na yung formula. Tapos, anong mangyayari? The tendency na naman is for you to memorize, ano. Nung sine-check ko yung test ninyo, midterm exam, ganun nga yung nakita ko, ano, nagme-memorize ng formula, pero hindi naman ukma, ano, hindi naman ukma yung minimorya, ano. So, kasi iba na yung circuit, na. So, dapat, very flexible kayo, ano, pag nag-iiba ang circuit, dapat tingnan nyo kung ano yung formula na mababago, ano. And then, usually naman, ano, you can do that using circuit analysis, ano. So, like in this case, ano, you will be tempted to memorize, ano, the formula that is written here, but then I discourage you, ano, I discourage you to memorize, ano. What you do is you do the circuit analysis. You are being asked here to write the formula for the voltage across the RB, ano. Ito. So, dapat muna, alamin muna natin yung mga polarity ng voltages before we can write, ano, the voltage equation or the loop equation, na. So, here, ganito yung current natin, ano, yung loop current. I'll just draw it here so that you can follow. So that is our loop current. So therefore, the voltage across RB, na, the VBB near the RB is positive, ano, the VBB is a voltage which is larger than 0.7, ano. So therefore, the polarity here will be plus of the voltage, ano, not the polarity, walang polarity ang resistor, okay? So, the polarity of the voltage across the resistor is like that, ano? Sorry. Okay? Dito, how about sa RC naman? Ang polarity ng voltage natin across the RC, dahil ang VCC mo at this point dito, positive, so you will have your plus also. No? And then minus. Okay? So, I will draw the loop current here. So, ganyan yung loop current. Okay? So, let's look first at the input side. Na, ang input side itong base emitter, no? This one is the input side. This one is the output side. Okay? So, writing the formula, the loop equation, ano? So, pumasok sa VBB. So, I will be writing it as negative VBB, no? Pumasok sa negative. So, be very flexible, ano? Kung ang ginamit ninyo ay polarity kung saan lumabas, parehas rin dapat tayo ng magiging resulta. Okay? So, negative VBB plus the voltage across RB na plus VBE. Okay? Equal to 0. I am writing the loop equation at the input side dito sa base emitter. Tatatlong voltahe lang. For this particular circuit, okay ito. Kasi walang resistor dun sa, kung mapapansin niyo, dun sa emitter, walang resistor, ano, dun sa emitter to ground. Okay? Pag nagkaroon ng resistor sa emitter to ground, hindi mo na pwede gamitin itong formula na ito kasi may dadagdag na voltage. Okay? Voltage drop, sorry. So, negative VBB is equal to, negative VB plus voltage across RB plus VBE equal to 0. So, that is your loop equation. So, we can write now, wait lang ha, nahirapan ako dito sa pen to. So, negative VBB plus, what is the formula for voltage? V equal to IR. So, ano yung dumadaloy sa RB? O di IB, no? Base current. IB, RB, na? Plus VBE equal to 0. So, therefore, computing for the IB, you will have IB, just algebraic manipulation, IB is equal to BBB, algebraic manipulation, lipat nyo sa kabila, no? Yung BBB, at saka yung BBE, no? This one is BBE. So, minus BBE divided by RB. So, that is your formula for IB, yung tinatanong, ano? So, tama naman, ano? Yan, IB is equal to BBB minus BBE over RB. Ano? You do not need to memorize that. You do the analysis like this one. Okay? You also calculate, ano? Meron pa bang sinasabi? Okay, dito naman, what is the voltage across VCE? Ano? That is the same circuit. Ano? So, ang gagawin naman natin, i-write ko lang yung sinulat ko kanina dito, ano, the loop equation. So, you will have here the loop equation. This one is the output side, ano. So, ano yung polarity natin dito kanina? Plus, and then, minus. Okay? So, doing that, ano, you will have negative VCC. You just follow, ano, yung arrow, yung loop current, pumasok sa negative. So, negative VCC plus voltage across RC. Ano pa? Plus VCE equal to 0. You are being asked for VCE. So, therefore, VCE is equal to VCC minus V voltage across RC. So, therefore, VCE will be equal to VCC minus, what is the voltage across RC? V is equal to IR. Ano? ICRC. Na? ICRC. Okay? So, di ba? I did not memorize. Ano? I just analyzed. That is the same thing that I got here. VCE equal to VCC minus ICRC. Okay? So, you just remember also that your IC is equal to beta IB. Na? So, for this one, for this example, na, you are being asked for IB, the IB, IC, IE, this must be subscripts, ano? Hindi lang siguro na subscript. Okay? So, again, we are going to write na the loop here. So, this is our loop. Draw pala, sorry. Dito naman, this will be our loop. Remember, your IE is this, na? So, if your di ba, you know naman the formula that IE is equal to IC plus IB. Na? So, your IB will be here. And then your IC will be here. It's in this direction. The polarity of the voltage across RC, because your VCC is connected this way, so this will be plus, minus the voltage across RC. What is the voltage across RB? The polarity will be plus, minus. Again, ang polarity para sa voltage, ano, resistors do not have polarity. The polarity that I am writing here, these are the polarity of the voltage across those resistors. We still have another voltage on the input loop. You have the VBE. Since this one is an NP, ano? So, N emitter, P base. So, the polarity here for the VBE will be like that. Na? So, this is the VBE. Okay? So, when you solve that, you are being asked for IB Okay? So, you write your loop equation. Okay lang kung sulat ka ng formula, ano? Kasi, pag nag-iba ang circuit, for this particular circuit, you can use the formula that we had on the previous slide. Pero pag nag-ibang circuit, kung hindi ka sanay mag-circuit analysis, then you will have a hard time. So, kaya dito pa lang, magsanay na kayo ng circuit analysis. Ano? So, again, you will have your negative VBB plus voltage across RB plus VBE equal to 0. So, therefore, your VRB is V equal to IR. So, IB RB para sa VRB, no? Equal to VBB minus VBE. So, therefore, your IB is equal to VBB, which is 5 volts, minus your VBE is 0.7 volts for silicon divided by RB. And your RB is 10 kilo ohms. Now, I always write, the whole, hindi ko siya ilalagay na 10. Yung iba kasi, they just place 10, tapos nalilimutan nila na kilo pala yon. Kaya tuloy yung answer nila, yung final answer nila, mali. So, I write everything, So, your IB here is equal to 5 volts minus 0.7 divided by 10 kilo ohms. So, your IB is equal to 430 microampere. Okay. So, the beta is given. What else can we solve here? We can solve the IC, because the beta is given to be 150, So, therefore, IC, memorize nyo na ito, IC is equal to beta IB. So, therefore, IC is equal to 150 times 430 microampere. So, your IC will be equal to 64.93 milliamperes. So, ito yung sinasabi ko na you do not simply estimate IE to be equal to IC, Kasi you can compute naman. Basta mako-compute, i-compute, So, your IE is equal to IB plus IC. So, that is equal to 430 microampere plus 64.93 milliampere. So, your IE will be equal to, wait lang. Sorry, may mali akong nasulat na number. Wait. Hold on. This is wrong. This is 64.5. So, this is 64.5 milliamperes. Okay? Ayusin na natin. Okay? So, this is 64.5 milliamperes. So, therefore, your IE will be equal to 64.93. Okay. Hey, teka, wait lang. I'm having a hard time with this one. Okay. So, this one will be 64.93 milliamperes. Okay. So, you are asked for, okay na yung IB, IC, and IE natin. We are looking for VBE. O, syempre, you know naman what VBE is. You simply write it. VBE is equal to 0.7 volt. Kapag ka hindi na-mention kung germanium or silicon, you always assume it to be silicon. So that is 0.7 volt. VCB. What about VCB? VCB is the voltage from collector to base. How do you compute it? You cannot compute it yet, right? You compute first for the VCE, ano? So for the VCE, you look at the right loop, ano? Yung nandun sa outer loop. So we will be writing now the equation for the outer loop. So dito tayo, no? Sa dito. Okay? So you will have here negative VCC plus the voltage across RC plus VCE, right? Because you know that your VCE, the polarity of VCE is plus here and then minus here. Okay? So that is equal to 0. Summation of voltages in a closed loop is equal to 0. So therefore, VRC is equal to VCC minus VCE. So, sorry, not this. The VCE pala. VCE is equal to VCC minus VRC. And that is equal to VCC minus ICRC. So you just substitute, ano, this will be equal to 10 volts minus our IC is 64.5 milliamperes, and then your RC is 100 ohms only. So your VCE is equal to, when you compute that, that will be equal to 3.55 volts. So that is the voltage across the collector and then the emitter. Okay? 3.55 volts. Okay? So what else? The VCB. So how can we compute for the VCB? Dito na lang. Okay, wait lang. Okay. So the VCB, diba, you know that the VCE is equal to VCB plus VBE from the formula that we had a while ago na anyway, VCE is equal to VCB plus VBE. So using it here, VCE is equal to VCB plus VBE. So you will have here so therefore your VCB will be equal to VCE minus VBE, right? So therefore you will have here 3.55 volts minus 0.7 volts. So your VCB now will be equal to 2.85 volts. Ano? So that's how yan na lahat, ano yung hinahanap. And then you just simply pakibox na lang yung mga answers, ano, sa test ninyo. Okay? So, so I will not box it this anymore kasi ang layo, ano. I-box kayo na lang, i-box ninyo. So, VBE, etc., ano, you just box everything dun sa final answer. Okay? So, that's how you do the analysis. Na? You do not rely simply on yung formula na hindi naman standard formula, ano? Yung do not rely on the formula that was derived from the standard formulas, no? So, ang mga hindi na nagbabago na formula, yung IE equal to IC plus IB, beta is equal to IC over IB, alpha is equal to IC over IE, na? Yung VCE is equal to VCB plus VBE. Those are yung formula na kailangan yung i-memorize, ano? Pero yung formula na ganito, no, ganyan, at saka yan, huwag yun na yan i-memorize, ano? Kasi, pag nag-iba ang circuit, iba na rin ang formula. So, imagine, ano, if you will be memorizing a lot. Okay? So, these are the answers, ano? So, yan yung mga answers natin kanina. 430 micro, 64.5 milli, etc., etc. Okay? So, again, this is your review. You just review this, ano, mga basic, nabanggit ko naman lahat, ano. Do not forget how to write the polarity of voltages, ano. Do not forget how to write the directions of current, na. As I have said, ano, the IB equal to VBB minus VBE, yung last three formula, ano, yung IB at saka formula for the VCE, that is applicable only for that particular circuit. Okay? Hindi kagaya nito, ito, and then this one, ano, this will not change, na, kahit NPN or PNP. Yung IB and VCE, that changes, depende sa circuit na meron ka. Okay? Do you have class after this? Are you still here? You have class? Yes, okay.
Yes po.
Yes, okay. Hold on. Okay. I'll just look kung ilan kayo. So there are 4 who were not able to attend the class. No? So anyway, the recording is here. Be sure that